This video is going to work through some review related to our linear systems of equations that we have been doing over the last couple weeks. And we're going to start off though with some review of the basics of graphing lines, combining like terms, evaluating, and then getting into our systems methods in the backside of the worksheet. We'll start off with our first problem, that is just graphing a line. So we've talked about different ways of doing this, but when it's in intercept form, typically we'll take the y-intercept and the slope and graph it from there. So we're looking at a problem where we've got the value of 5 right here that's kind of standing on its own. We know that's our y-intercept value. And then the mx term, the number next to the variable x, is our slope, the coefficient here. In front of the x is our slope. Remember that minus sign goes with it, so we've got -3/4 for our slope, which means our rise is -3 and our run is going to be +4. So we're going to put that negative sign up with the numerator. Remember to graph this then, we're going to use our y-intercept point first. That y-intercept value of 5 means our y-intercept point is 0, 5. So 1, 2, 3, 4, 5. And then our slope, our steepness, is going to go from that y-intercept value. We're going to rise -3, which means we're going to go down 3. And then we're going to run +4, which means we're going to go to the right 4. 1, 2, 3, 4. Now we have 2 points graphed, and that's all we need in order to graph a line. So now we can use a straight edge here and go ahead and graph that line. So go ahead and do that same thing. We're going to do the same thing in number 2. Again, we're going to take a look at what the y-intercept value is. So 3x minus 1, that minus 1's standing on its own as the y-intercept, and that +3 is the coefficient of the x, so that is the slope. Remember, when it is a whole number, we can think of it as 3 over 1, or whatever the whole number is over 1. So the rise over run would be 3 over 1, +3, +1. So we'll go back now to our y-intercept point, which is -1. And then we will use our slope to track down our next point. So we will rise from our y-intercept, we'll rise 3, 1, 2, 3, and run +1. If you'd like to repeat that pattern, rise 3, run 1, you certainly can, or reverse it down in the bottom here, down 3 and left 1 is the same thing as rising 3 and going to the right 1. All you need is 2 points though, so if you just had 2 points, that's fine. If you wanted to graph more than 2 points and continue that pattern, that's fine as well. And then we should connect those up and extend that line past the points. Draw arrows on both sides. So remember then, in this unit we were graphing, but we were also doing a lot of work with substituting and evaluating equations. So we talked about if we have 2 linear equations, which we do have here, that we can substitute one equation into the other equation. The equation that we want to substitute is the one that is in either y equals or x equals form. So look for the y equals or x equals equation. All right, and this one we've got y equals -2. So we want to circle what's after the equal sign there and think about substituting that into the second equation. Since it's y equals 2, we're going to put it in for y. And then we're going to rewrite that second equation, 3x plus the substitution. So I'm just going to put that into parentheses for the moment. So 3x plus -2. So instead of 3x plus y, we're replacing the y with the -2. We're making that substitution. We're trading it out. Equals 13. All right, so now we're going to solve this. Now notice there's no distributive property right here. And we've got actually some parentheses and some extra symbols here that we don't really need, but we're just going to keep that for now. We're going to be able to go right into our solving. So we're going to undo the adding of -2. So the opposite of subtracting 2 ultimately is adding 2. That cancels this out, so bring down what's left. We have 3x then equals 15. And then to undo multiplying of 3, this is 3 times x, so to undo multiplication we will divide. Bring down what's left, we've got x equals 5. All right, so we have x equals 5, So that's our x value of our solution. And you'll notice in this particular case, we could plug it back in here, but wait, we already got the y value. It tells us the y value is -2. So this is maybe an easier substitution problem. On the back side, we're going to get to the ones that require a little bit more work. But this then is our solution. This is the point of intersection of these two lines. We're going to do a similar technique with number 4. Again, look for the equation that's in either x equals or y equals form, and then substitute. Oh wait, in this problem we actually have both equations in x equals or y equals form. So we could either take the 9 and put it into the second equation, or we could take the 12x minus 8, put it into the first equation, except for there isn't a y in the first equation, so that really wouldn't make much sense. We already have the x value. So let's take that 9 and let's substitute it into the second equation in spot of x in place of the x. So we're going to plug that in. We're going to substitute that in. We're going to rewrite that equation. Y equals 12 minus 8 times 9. Instead of 12 minus 8 times x, we now know x equals 9, so we're going to replace the x with 9. And now we're going to simplify this. So y is already by itself, so really we just have to use our order of operations and simplify what's over here. So we've got 12 minus 8 times 9 is 72, and 12 minus 72, maybe you can't do that in your head, maybe you can, but that is going to turn out to be -60. So use your calculator if you need to. And so now we've got the y value of -60. And if we look back again, we already have the x value. It tells us x is equal to 9. So both 3 and 4 are a little bit easier substitution problems because the original equations already have the y value or the x value listed. Okay. All right, so another thing that we're going to be doing with our methods is using the elimination method on the backside, which requires us to combine two equations together. So let's just practice that. If it says to add these equations together, that means, or add these expressions together, then we're going to just add -2x plus 13x, so that would be a positive 11x. That's all you've got to do there. Next one, it says to subtract, so we're going to put a little subtraction sign in there. -5y minus 11, so -5 minus 11 is -16y. On this one, it says to add, so we're going to put an addition sign in both of those spots there, combining our like terms here vertically. -4x plus -8x would be -12x, and -2y plus 7y is going to be a positive 5y.